Welcome back, everybody. So we just wrapped up working with law of sines. We're going to go ahead and look at the law of cosines. The law of cosines is helpful for two very specific non-right cases. Again, these are triangles that don't have a right angle. And the two cases are side angle side, that's what this stands for, and side side side. So whenever you see a non-right triangle that has either a side angle side measurement. So for example, you might have a triangle that has a side measurement of 12, a side measurement of 11, and maybe an angle on the inside sandwiched between those two. Maybe it's like 51 degrees or something like that. So again, that is what side angle side will look like. Again, this is usually called, another phrase for it is included. So whenever you see something that says the included angle, that would mean that your angle is just sandwiched or included in between 12 and 11, or those two sides, and you'll be good. And of course, side, side, side is pretty much self-explanatory. So say you're given a triangle that they give you all three sides. So you have 6, 7, and 21. I don't know, whichever it's going to be. That's our side, side, side case. So you would use the law of cosines. Now, the law of cosines, you'll see in the purple box down here, there are three separate equations, so don't get worried. We're not using all of them at the same time, just one. So we'll go ahead and just go through and see some examples. So again, just to reiterate, when you use the law of cosines, whenever it's a non-right triangle, and it's got to be non-right, not have a right angle. And whenever, because if it was a right angle, we just use SOHCAHTOA. We just use right triangle straight. That would be it. And again, usually side angle side or side side side. Any other one, really use the law of sines from the last video. It's a little bit easier. Wouldn't work than any other case. So let's take a look at a problem here. So first thing is I have the law of sines on the top. Always reference it. Maybe make an index card or something for yourself, just because you do want to have access to it as you're working through, and you don't want to waste precious brain space by memorizing this, just because you need brain space to look at other things. So solve for angle. So it's a solve for angle C, round to a whole degree. So they give us some information on the side over here. They say A is 6, B is 8, and C is 12. And if I take a second to pause and just ask yourself how you would get started, some of you might say, oh, I'm not really sure. Are those sides or angles that they gave me those measurements? And if you remember from last time, what we've discussed before, remember lowercase letters or variables indicate a side measurement. So what I'm going to go ahead and do, I'm just going to make a triangle. I'm going to label it A, B, and C. Now I'll say I am right-handed, so I usually draw the triangle the same way kind of every time. So you might draw it a little differently. That's okay. Just as long as when you label your sides, they match up to where the angles are. So A is 6. So that means that across from this A angle, I'm going to go ahead and get across. I'm going to go ahead and I'm going to put 6. Across from the B, I'm going to go ahead and put 8. And across from the C, I'm going to go ahead and put 12. And then if I go back to my problem, it says to solve for angle, and actually this should say angle A. So, whoopsies. But so it should be angle A. So we're going to solve for angle A on this problem. So we'll tape over there. So, first thing is with the law of cosines, again, you see there are 3 different equations. You don't want to use all 3. You just want to use the equation that you need. The equation that I need in this case, if I'm looking for angle A, I'm going to use equation A, right? So this is the one I'm going to use. And so what I'm going to do is I'm going to start this problem by just rewriting this formula so I don't mess up and I don't, make a mistake when I'm plugging things in, et cetera, et cetera. So the more organized you are, the better you're going to do with these problems. So just keep it set up and you'll be good. So it's going to plug in everything we know. So A, our measurement for A is 6, right? So 6 squared. Our measurement for B, we already know that, it's 8. 8 squared. And our measurement for C is 12. And then we're going to go ahead and plug in B and C. So it's minus 2 times B, which is 8, and C, which is 12, and then cosine of A. Again, that capital A is what we are looking for in this problem, that angle. So of course now, you might be thinking, okay, like this seems pretty easy. Like, yes, it is. And if you don't think it's easy, that's okay. We're going to work through it and get through it together. So let's go ahead and simplify. So 6 squared, 36. Love those simple squares. 8 squared, 64. Right? 12 squared, 144. And then we've got 2 times 8 times 12. So I'm going to put my minus sign. 2 times 8 times 12 is going to go ahead and be 192. Right? We have cosine of A. Right? So let's go ahead and simplify. So I'm going to go ahead and combine the 64 and 44 because they are just single constants together there. So I'm going to add them. So it's 208 minus 192. And so then I'm going to go ahead and just solve. So I'm going to go ahead and I'm going to subtract 208, just like a basic equation. I guess it's not so basic because we're doing a lot of trig too, but 36 minus 208 is negative 172. And I've got negative 192 times cosine of A. And so now to use inverse operations, I have to make sure that I'm going to go ahead and remember, I want to undo what is attached to that cosine because I want to get to that A that's inside that parentheses, that's inside that cosine, that's inside this piece here. So I'm going to go ahead and I'm going to divide by negative 192 because the inverse or the opposite of multiplying by negative 192 is by dividing by negative 192. So now, of course, for some of you, you all kind of know from the last video, I like to wait until the end to use my calculator so that I'm not doing all this extra work. So what I'll do is I've got cosine A here because these two canceled out. And then negative 172 divided by negative 192. Well, I do know that, negative divided by negative is positive, so I'm just going to go ahead and use this fraction right here. And then, similar to the last video, one of the problems we looked at, whenever you're looking for an angle, you want to use that inverse trig. Inverse trig. Remember that inverse trig, again, when looking for an angle. An inverse trig is going to be our inverse cosine. So last time we used inverse sine, law of sines, but now we're going to go ahead and we're going to use that inverse cosine, right? And this is what it's going to look like in the calculator on the left side here. So cosine with the negative 1 as the exponent. So if I go to our calculator, right, make sure you're in degree mode. Remember that key point from last time. And remember, how do we get to inverse cosine? So think a little bit. Second cosine, right? I see my little negative 1 pop up. That's how I know I'm in the right spot. And it's 172 over 92. 172 divided by 192. And, ooh, look at that. All right, I get 26.384. So you all know I enjoy the 2 decimal places, so 26.38. So 26.38 is our angle. So I'm going to go ahead and pop a little degree symbol in there. So 26.38 is our angle using law of cosines. All right. So if we were going to summarize this, first thing you want to do is just set up your equation, set up your diagram, your triangle, see what information you have. Next thing is just determine which equation you want to use. Do you want to use a squared? Do you want to use b squared? Do you want to use c squared? It's really just depending on what you are looking for. And then you really just have to solve for your unknown variable. So, that was the first one. Let's go ahead and do another one. And this time we're going to look for a side of a triangle. And I I think a lot of you are going to be really happy with the way this problem goes. It's a little less work. So, sample 2, take a deep breath. Use the given information to find the third side of the triangle. So again, I'm going to take a look. So I'm going to go ahead and I'm going to sketch out a little diagram here. Oop. Right. I'm going to go ahead and just label. Again, I usually label the same way every time. It's just how I am. It's just what I do. So it gives me angle A is 50 degrees. So I'm going to go ahead and I'm going to put 50 degrees right on here. Lowercase b, or side B, is 15. So here's B, right? So I know that side B has to be across from it. And then side C, side C is 30. So here's angle C. So side C is across from that angle C. So I'm going to put right here 30. So what kind of triangle is this? Well, it's obviously non-right because there's no 90-degree angle in the problem or the formula or anything like that. And then I see that this 50 degrees is sandwiched between these two sides. So that's our SAS case, side angle side case. And we are going to go ahead and we are going to look for our third side. So this tells me I'm going to use law of cosines. So the law of cosines, right? Remember, we are looking for side A, right? So what I'm going to do, I'm going to use my equation for A, right? So A squared equals B squared plus C squared minus 2BC times cosine A. So now A squared, so lowercase a, because it's the side. We're going to leave this first part blank on the left side. A squared, we're just going to leave it there. B squared is going to be 15 squared plus 30 squared minus 2 times B times C, which is 15 times 30. And then cosine of angle A. Do we have angle A? Yes, we do. Oh my gosh, 50. And then if you're looking at this, some of you are like, oh my goodness, what can I do? I can just go into your calculator, right? I'm going to pull that up. And we can really just start simplifying. So let's go ahead and do that. So 15 squared, no, I don't want that, plus 30 squared, and then what was it, minus 2 times 15 times 30, and then I believe we had cosine of 50, right? That was our angle. Make sure you shut your parentheses. And oh my gosh, how great is that? I can just put that all in one calculator swoop. 546.49, I'm going to use that. So 546.49. Now I want you to think to yourself, are you done with this problem? If you're saying no, you would be correct. We have a squared equals 546.49. And also, if you look at the problem, our measurements are 30 and 15. It would really be impossible to have a 540 foot-long triangle and everything else is that small. So I need to go ahead and use square root, right, to undo the square. So A is actually going to equal, I'm going to do second square root. I'm just going to use 546.49. If you want to put in the 1, you can, but it won't really vary your answer. So I'm going to get 23.38. And we don't have to do positive or negative, unlike other classes in the past. And just think about why, this is distance. You can't have a negative distance, right? That means that we'd be in a black hole somewhere, and I don't want to be there. So, and here you go. This is your side measurement. Again, law of cosines, very quick when you've got a side. So just think about those. All right. Thank you all very much. I'll make some more videos later. And just, if you have questions as you're working through your ingenuity, make sure to ask them. I can't wait to see you more. Have a great day. And good luck. You're going to do great.